Greetings, and welcome to this introduction to regression discontinuity. My name is Chris Curran, and I'm an assistant professor of public policy at the UMBC School of Public Policy. In this video, I'll introduce regression discontinuity, also commonly referred to as RD, as a method for addressing selection bias in quantitative studies aimed at estimating causal effects. To begin, let's talk a little bit about why we would need to use an RD, or regression discontinuity design. In our previous discussions of selection bias, we've talked about the problems with estimating clean causal effects. And this primary problem is that of selection bias. The two groups, the treatment group and the comparison group, often differ on a lot of characteristics other than treatment. For example, we could imagine two groups of students. One group of students who has excelled academically, has a high GPA, maybe has done really well on the SAT or ACT exam, and perhaps has all sorts of other advantages, having gone to high-performing schools, experienced great teachers, having lots of neighborhood and home supports, and so forth. And we can imagine a second set of students, perhaps that is less advantaged, and has not done as well academically, has lower GPAs and perhaps lower scores on a test like the SAT, and we can imagine these lists continuing off the bottom of the screen with lots of other differences between these two groups. Well, let's imagine that we wanted to understand the effect of some intervention given to one of these groups of individuals. So take, for instance, a university that might offer a financial aid policy to incoming students based on their past academic merit. Well, let's imagine that a university offers a scholarship to students that make some score on the SAT, say perhaps a 1350. Well, if we thought about later outcomes for those students, say academic performance in college or graduation from college or future earnings in the labor force, it wouldn't come as much of a surprise to us that the groups of students would likely look different. So if we imagined graphing this and showing it graphically, if we put on the x-axis the student's incoming SAT score, and we imagine the y-axis being some measure of later performance, I'll abbreviate this with PERF here, we might expect to see a positive trend or relationship between the two, such that students that did better in the past, performed higher academically on the SAT, had better outcomes later down the road, perhaps performed higher in college, were more likely to graduate, or had better labor market outcomes. Well, if we imagine then that a school is providing a scholarship to some group of those students, say the students that score a certain score, like a 1350 on the SAT, if we naively compared outcomes of students that get the scholarship, that's those on the right, to students that did not get the scholarship, those on the left, it should come as no surprise to us that students with the scholarship perform better later on. But the problem is that we can't necessarily attribute this to the scholarship. As we just suggested, the students that sit on the right of the 1350 line probably have lots of other advantages. Not only was their SAT higher to begin with, but they were more likely to come from households that likely had higher levels of income, higher levels of parental education. Perhaps were able to invest more in those students' academic outcomes and abilities. Comparatively, students on the left that did not qualify for the scholarship had less of those advantages, and consequently we would expect them to have lower outcomes regardless of whether they received a scholarship or not. Now, we've seen other methods that can address this kind of selection bias, one of the basic ones being just regression. And so I'll emphasize in this mini lecture that regression discontinuity and regression are, though perhaps relying on the same underlying mechanism of fitting a line of best fit, are different types of research designs. So ordinary least squares regression, or regression with control variables, can get us some distance of accounting for differences in two groups. We could account for, say, GPA or parental education. However, there might be lots of things that remain unaccounted for that could still bias the estimates. The beauty of an RD is it's going to get us to what is arguably causal estimates of the same credibility almost as a randomized control trial. And we'll do this in the case of an RD by exploiting some unique facts about the cutoff that qualifies students for the treatment. So let's imagine those students again. We had a student perhaps that sits way up here at the high end of the SAT distribution, and a group of students that sits way down here on the left at the low end of the SAT distribution. Now, it may not come as a surprise that the student to the far right is perhaps different in many ways, we'll color him or her in green, than the student that sits at the far left. We'll give this student a purple color. Again, these differences may relate to parental education, family income, neighborhood environment, school quality, and so forth. However, if we think about students who were very, very close to either getting the scholarship or just missed getting the scholarship by a few points, in other words, students that sit just below this 1350 cutoff or students that sit just above this 1350 cutoff, we could imagine that those students actually are quite similar. And in fact, in earlier lectures, we've talked a little bit about issues of measurement error and the idea that anytime you sit down to take a test like the SAT, there's some randomness to the score that you will get. Perhaps you guess a question right, perhaps you mismark an answer that you really should have known, perhaps you're distracted at one moment, perhaps you do a little better because of your testing in a classroom that you're comfortable and familiar with. The regression discontinuity design will actually exploit that type of measurement error and the closeness of individuals right around a cutoff to give us causal estimates. So here's the intuition. Students who fall just to the right or just to the left of the cutoff are arguably quite similar on both observable and, importantly, unobservable characteristics. In other words, we can imagine that if we were to, say, zoom in and just look at students right around the cutoff, say right about here, that we can almost approximate an RCT. That in other words, whether a student had a 1348 or a 1352 on the SAT is a bit of a coin flip, essentially a small randomized control trial occurring right there at that cutoff. And in virtue of measurement error and randomness around that cutoff, this is often arguably a reasonable thing to argue. So if this is the case, what we can do is exploit this arguably random variation right around the cutoff to get credible causal estimates. So what we can do in an RD is, just to draw the same graph again, think about this cutoff. So here's SAT and performance. And here's our line for qualifying for the scholarship. And we can try to make estimates that look for a discontinuity at that cutoff. So here I show the relationship between SAT and performance, and we notice that just like before, it's a positive relationship. But we see a jump at the 1350, the score that was necessary to qualify for the scholarship. So again, students on the right get the scholarship, and students on the left do not. But arguably this jump caused by the cutoff is exogenous, and particularly for students right around the cutoff, we can say that this is approximating a randomized control trial. So if we're interested in then estimating the causal effect of some policy, in this case the scholarship, we can imagine that that effect is essentially equal to this jump or this discontinuity that occurs right at the cutoff. And so our interest is in estimating this jump, this discontinuity, and claiming that that is a causal estimate. So this should give you a bit of a view of the intuition of regression discontinuity. The idea here is that we can exploit a naturally occurring cutoff, such as an SAT score that qualifies a student for a scholarship, to arguably make a case for exogenous variation and a causal estimate. In the future slides, we'll look at some of the requirements for being able to do this, as well as some of the threats to this research design. Well, thank you so much, and I hope this is a useful introduction to the RD approach.